Okay, let's talk through this one. This is exercise 10A. Try not to read ahead with the solutions there. And also, I do expect that you actually tried with a pen and paper to try to do these before you've looked at these solutions. So please, I trust you to do that. Number one, the first three terms of a geometric sequence are 3, 6, and 12. Write down the common ratio. Well, the common ratio of a geometric system is defined as un plus 1 over un. So that would be u2 over u1, for example, or u3 over u2. So here we're going to put u2 over u1, and we've got 6 over 3. Now that should equal 12 over 6 if it's geometric, and 12 over 6, they both equal 2, so r is 2. That's the common ratio. Calculate the value of the 15th term. Well, we use this formula here that's in the book. Un, that's called the nth term, is equal to u1, that's the first term, times the common ratio to the power of n minus 1. Now in our case, the 15th term, u1 is 3, r is 2, and the n minus 1 would be 15 minus 1 is 14, and the answer is 49,152. Let's have a look at number 2. A marrow plant is 0.5 metres long. Every week it grows by 20%. Now if it grows by 20%, the 0.5 is going to get larger each time. So be careful. R is not 20 over 100. It's not 0.2 because then 0.5 wouldn't get any bigger. We have to add a 1 to that. So we go 1, that's the initial size, times 1 times 20 over 100, which is 1 plus 0.2. So R is 1.2. Okay. Then calculate how long the plant is after 12 weeks. Now this is what I was saying in the examples. When they say after 12 weeks, that's the end of 12 weeks. So that's where this gets a bit confusing. So what I do is I then say, well, if that's after 12 weeks, we have to look after the first week. So at the end of week 1, the plant is 0.5 times 1.2. So that means it's 0.6. So it's increased from 0.5 to 0.6. So I use the original 0.5 as like the 0 term, and then u1 is that because that's at the end of the first week. So I put the u1 in here. Now we're staying true to the formula. Remember, the formula is un equals u1 times r to the n minus 1. So I've used 0.6, not 0.5, because it's the end of the first week. Because their question was, what is it after 12 weeks, at the end of the 12th week? Now r we said was 1.2. The formula says it's n minus 1. Well, the 12th week is going to be 12 minus 1. It's 11. And that's the answer. Now this is a different answer to the book. The textbook used 0.5 there, I think. Okay. So, but I think this word after 12 weeks is important. Okay. That's okay. I mean, it's the way we've interpreted the question there. C, comment on the predicted length of the marrow after 1 year. Well, the textbook says something like this. Can't predict that far into the future for a living thing. Well, things don't go on forever. That's all it means, especially if it's living. Right. All right. Okay. So hopefully that satisfies, that answer satisfies that question. Now, number 3, it says, the first 4 terms of a geometric sequence are 27, x, 3, and 1. Now, they've already told us it's geometric, so we don't have to check. But we can set this up. If we've got the first term, the second term, the third term, and the fourth term, and we know that r is the next term over the previous term, or un plus 1 over un, okay, find the value of x. Well, what we need to do first is to find r. So we're going to find r, and here we've got r is 1/3. Okay. And so if r is 1/3, and we know that there's different ways of doing this, but look, if you find r first is 1/3, because 1 over 3 is 1/3, right? u4 over u3 is r. You could do it in ratios as well. Therefore, the second term, using our formula, un equals u1 plus r to the n minus 1, we know that u1 is 27, so it's u2 equals u1, that's 27, r to the n minus 1. Well, that would be 2 minus 1 is 1, so u2 is 9, so x equals 9. Okay. B, find r is 1/3, so it looks like they probably set up x over 27 equals 1 over 3 and solve for x. Right? X over 27 equals 1 over 3. You can always do it that way as well. C, calculate the value of the eighth term. Well, we know R, we know the first term, so we can just put U8 equals 27, that's U1, times R to the 8 minus 1, which is 7. That's the answer there, which is actually the same as that. Okay, so that is actually 3 to the power of minus 4. Okay, 4. There is a flu epidemic in Cozy Town. On the first day, 2 people have the flu. On the second day, 10 people have the flu. On the third day, 50 people have the flu. Show that the number of people with the flu forms a geometric sequence. Okay, so the first term on the first day is 2, so U1 is 2. On the second day, it's 10, so it's 10. And on the third day, it's 50. Well, for this to be geometric, we said that 10 over 2 must equal 50 over 10. 10 over 2 equals 50 over 10. And that's true, they both equal 5. So it's geometric. B, hence, assuming the conjecture is true, calculate how many people have the flu after 1 week. That's after 7 days. So U7, we know U1 is 2, and we know that the ratio is 5, so it's 2 times 5 to the power of 7 minus 1, which is 6, and that's the answer in the book. C, hence calculate how many people will have the flu after 1 year. Comment on your answer. Well, again, the book says something like this. After 1 year, n equals 365, and u to the 365 is 2, which is the first term, times the ratio to the power of 365 minus 1 is 364. Okay, now that's a pretty big number. This number is extraordinarily high, so is unlikely to be reached for several reasons, including the population of the town and the nature of the viruses. Okay, well, viruses, their infection rate changes with seasons and everything else, so there's a lot of factors involved. So when the question says, comment on your answer, and also they talked about the population of the town, didn't they? The population of the town can't be that big. Well, it could be, but I mean, it's a pretty big number. Okay, so 5, the second term of a geometric sequence is minus 32. And the fourth term is minus 2. Given that all the terms are negative, find the common ratio in the first term. Okay, so U2 is minus 32. The fourth term is minus 2. All terms are negative, so R is positive. So if all the terms of this, each term is negative, then R must be positive, because if R was negative, they would alternate signs, wouldn't they, between positive and negative. Now it says given that all the terms, find the common ratio. Okay. Well, the common ratio is defined as U2 over U1 equals U3 over U2 equals U4 over U3 equals U5 over U4. So we can set up this. We can say that U4 on U3 must equal U3 on U2. Okay, it tells us it's geometric, so we can do this. If we cross multiply, we've got U4 times U2 equals U3 squared. Now we know U4 is minus 2, and we know U2 is minus 32. So minus 2 times minus 32 equals U3 squared. Okay. Now, if we take the square root of both sides, right, the square root of this becomes 64. So the square root of 64 of both sides. The answer is plus or minus 64, plus or minus 8, right? Going to be plus or minus 8. But they tell us that all the terms are negative. So U3 can't be plus 8. It has to be minus 8. Okay. Because remember, minus 8 squared is equal to 64, and also plus 8 squared is 64. So we know U3 is minus 8. It's not plus or minus 8. It's not plus 8. It's just minus 8. So if we already know that the common ratio is, if we already know that term 3 is minus 8, then we can just come back to this one and say that minus 8 divided by minus 32, in this case, the fourth term, okay, the fourth term is minus 2. We can do it that way. So minus 2 over minus 8, so it's U4 divided by U3. Okay, we could have done U3 over U2 as well. So we've got minus 2 over minus 8 equals a quarter. R is a half. Is a quarter. Sorry about that. So R is equal to U2 over U1, and we have to find 1 now. Since we know R and we know U2, we can say R equals U2 over U1. So U1 equals U2 over R. Minus 32 over a quarter is minus 128. Thank you.